An archival science perspective on blockchains. Observed from a purely computational or technical perspective, it is not easy to see what all the fuss is about when it comes to blockchains, nor why there should be such interest in them. Blockchain systems like Bitcoin have features and capabilities that can be provided by existing systems. Tamper resistance can be provided by digital signatures with or without blockchain, as can the ability to prove a claim or achieve non-repudiability of a transaction. Message ordering can be achieved through the use of hash pointing without resorting to blockchain. And highly available storage needs can be handled by commercial cloud storage. Recognizing that it would be difficult to advance scientific discussions about blockchain technology without a stable definition of the term, in 2017, global blockchain experts became involved in an international project to develop a standard blockchain and distributed ledger vocabulary under the auspices of the International Organization for Standardization Technical Committee on Blockchain and Distributed Ledger Technologies. This work, which involved the input of over 300 international experts from 50 countries over the span of almost 3 years, resulted in what has become the first ISO standard on blockchain and distributed ledger technologies, ISO 22739. The working group that developed the vocabulary converged on a set of interlocking definitions that capture a shared understanding of what a blockchain is and, equally importantly, what it is not. After many months of deliberation, the ISO experts arrived at a definition of blockchain as a distributed ledger with confirmed blocks organized in an append-only sequential chain using cryptographic links, with distributed ledgers being defined as a ledger that is shared across a set of distributed ledger technology nodes and synchronized between the DLT nodes using a consensus mechanism. Thus, the term distributed ledger encompasses the concept of a blockchain because blockchains are a type of distributed ledger. ISO defined a ledger as an information store that keeps records that are intended to be final, definitive, and immutable. It is significant that the ISO experts did not define blockchain strictly in terms of technical components, such as the network databases that communicate and interact with one another over a network in order to implement a blockchain. ISO 22739 instead refers to these technical components as instantiating blockchain or distributed ledger technology systems. To attempt to understand blockchain purely in terms of the computational technologies experts understood is to miss the mark by focusing on the wrong abstraction layer, to use a concept from computing. In software engineering and computing, abstraction involves thinking about and representing a thing, for example, a system, at different levels of granularity or detail. Abstractions, like models, are representations that help simplify a complex world and focus the mind on important details. In contrast to focusing on the technical system view in its definition of the term blockchain, ISO TC 307 chose to focus on a higher level of abstraction. In ISO 22739, by recognizing blockchains as a distributed type of ledger, ISO experts connected blockchain with a long tradition of record keeping. This, in turn, connects blockchains to the theories, principles, and methods of archival science, which is the science underpinning record keeping. Archival science is an academic and applied discipline that involves the scientific study of process-bound information, both as product and as agent of human thoughts, emotions, and activities in its various contexts. Its field of study encompasses personal documents, records, and archives of communities, government agencies, and other formal organizations, and archival materials in general, whether kept by archival institutions, units, or programs. It covers both the records themselves and their contexts of creation, management, and use, and their socio-cultural context. Its central questions are why, how, and under what circumstances human beings create, keep, change, preserve, or destroy records, and what meanings they may individually or jointly attribute to records and to their record-keeping and archival operations. Archival science focuses on more than just records or archival documents to think about records or archival documents in context, meaning the context of the data within a record and the context of creation, management, and use, as well as the socio-political, cultural, and economic contexts underlying these contexts. Why should it be so important to recognize blockchains as record-keeping systems and connect them to archival theoretic concepts? For one thing, defining blockchains in this way makes it possible to treat them as a single category. No matter how many different types of blockchains and distributed ledgers there are now in the world, or there might be in the future, they all will have one thing in common: a ledger. Another reason is that record-keeping and archival theories, principles, methods, practices, and professionals have been long associated with the preservation of information created or received and maintained as evidence and as an asset by an organization in pursuit of legal obligations or in the course of conducting business. Evidence is here not limited to the legal sense of the term, but rather is information that could be used either by itself or in conjunction with other information to establish proof about an event or action. In order to offer proof of an event or action, evidence must be shown to be inviolate and complete. Thus, records, in order to offer evidence, must, among other things, possess the characteristics of authenticity, reliability, and integrity. It follows then that if we want to design blockchain and distributed ledger systems capable of creating, capturing, and preserving sources of evidence, record-keeping and archival theories, principles, methods, practices, and professionals offer knowledge and experience that can offer valuable guidance. It is the promise, if not yet the reality, of being capable of producing inviolate and complete evidence, or, as expressed in the definition of a ledger in the International Standard on Blockchain and Distributed Ledger Vocabulary, of being designed to produce final, definitive, and immutable records that sets blockchains and other distributed ledgers apart from other types of information systems, such as the commonly used transaction processing systems, management information systems, or office automation systems. Indeed, in a datafied world, the capability of producing and preserving immutable evidence, as blockchains are designed to do, is a rare one. As paper records and record-keeping have gradually fallen away to be replaced by digital records and record-keeping, greater value has been placed on ensuring that the information created by an organization in the conduct of its business can be reassembled into new information assets that might be mined to advance organizational strategy, more often than not profit-driven, or sold to other organizations for similar purposes. As the now well-worn expression goes, data is the new oil. New business models have arisen based upon exploiting information as assets. To enable these new business models, what once would have been created as records in fixed form is now created and kept in a malleable and manipulatable form. Datafication and the creation and storage of vast troves of information have given rise to the so-called era of big data and an entirely new field of endeavor, data science, frequently using artificial intelligence. While the ability to manipulate records by transforming them into novel forms of data has led to great innovation, it has also undermined the basis of societal proof about past events and actions. In the final analysis, blockchain, as a unique type of ledger, promises to restore and protect society's evidence base.